All right, so this is going to be the last section we're going to do for chapter 10. We're not doing the whole thing. We're just doing sections 4, 5, and 6. This is section 6, obviously. And this is known as operations with functions. This is pretty simple stuff, not too bad. So we're just going to take some different functions and we're going to perform different operations on them. But it's pretty easy. All right, so let's go ahead and dive into some questions here. Okay, so this one says we have two functions up here. We have an f function and a g function. It says identify the rules for the following functions. And it says f plus g. So literally, we're just adding the two functions together, which is combining like terms more or less. Okay, so a bunch of different ways you can do that as far as writing it out. It just depends on what you're comfortable with. In this case, I mean, you literally could just look at it and say, okay, I've got, let's get something that writes here. I've got, ooh, that's big. Might have to back that off a little bit. Hang on. So I've literally got a 2x squared, right? And then I go look for my x's, which I've heard they live in Texas, but that's an old country song. So we've got plus 5x and plus 3x. So 5 and 3 is 8. So it's just 8x. And then finally, we have minus 1 and plus 2. So 2 minus 1 is plus 1. And yeah, that's your answer. It's really that easy. Okay. So next one, we're going to subtract the g function. Okay. So this one I'm going to write out in a little different format. But again, like I said, if you're comfortable with doing what we just did, that's fine too. So this time we're going to subtract g of x. So let's try this. Let's go 2x squared plus 5x minus 1. All right, now if we're going to subtract this guy, we have to switch the sign. So this becomes minus 3x, and this becomes minus 2, which makes sense, right? When you subtract, you switch the sign and then add it together. So then we'll go do the same thing. We just add them column by column, nothing to add to here. So he stays 2x squared. Then we've got 5 minus 3, so it's going to be plus 2x. And then minus 1 minus 2 more is minus 3. And that's it. Questions on that? Easy peasy, right? Cool. All right, let's check out a few more. All right, so it looks like this one we're going to do some multiplication. And that's okay. So it starts off, it says, suppose the demand in units for a company's jeans at price X, so a certain price for these jeans, is 600 minus 4X. All right, so they really do this kind of stuff, like manufacturers and salespeople and stuff like that. They really do this kind of stuff, okay? So you see here it says revenue, so that's the amount of money you make. And that is the price multiplied by the demand for these. Now notice that it's minus 4x and x is the price. So as the price goes up, the demand goes down. And that makes sense. If something's too expensive, you're not going to buy it, right? Okay. You go to McDonald's, get a McDouble for $2 and some change, and all of a sudden they raise the price to $10. You're like, yeah, no. Right? So that's all that's going on here. So it says if revenue is price times demand, it says write the rule of a function r of x, so that'd be the revenue, which represents the expected revenue in jeans, and it says state the domain of the function. Okay, so you can't buy negative jeans, right? So we're going to have to say our domain is going to start at 1. And then it could go to infinity, but it's probably not going to. Okay. And here's why. Look at it this way. If you had, what happens with your demand is 0? Like, yeah, nobody wants this stuff, right? So you'd have to do 0 equals 600 minus 4x. Okay. So if we add 4x to both sides, right? If we add 4x to both sides, then you get 4x equals 600. Okay? And if we divide by 4, then we get x equals 600 divided by 4, which happens to be 150. So if the price of these jeans is 150 bucks, nobody's buying. Okay? And I agree with that totally. Since I'm used to paying like, 10, 12 bucks for a pair of jeans. I don't know about you, but okay. So the domain that they're talking about, that's the possible x values, would obviously be, they're not going to give the jeans away. So, but like say, they're having some kind of sale someplace, where they're just trying to get rid of them. The jeans could be $1 and go up to $150. So that's your domain. It would be $1 up to 150. Okay, so that's what they're talking about there. So we're just trying to look at something that would be a sensible value. And obviously 1 really isn't too much of a sensible value, for a pair of jeans, unless you're going to like Goodwill or something like that, right? Okay, so that's what they're talking about there. All right, so then the last one says, if the price is $40, how much revenue will a company earn? Okay, so, I guess we didn't finish off this part here. So if we have price times demand, says write a rule R of X, which represents, so we have the price, right? So the price is X, and the demand function is this. So we had to multiply those two guys together, and I didn't do that yet, but that's easy, right? So demand is going to be the price, which is just X, and then times the demand function, which I don't know if I can cram that in here or not, 600 minus 4x. Close enough, I guess. Okay. And you can leave it like that or you can multiply it out. Doesn't matter. All right, so it says if the price is 40 bucks, how much revenue will the company earn? So X is 40. So this is going to be 40, right? And then times this demand thing, right? So the demand thing, again, is the 600 minus 4x. That's going to be 600. And then minus 4. And then times 40. Okay. All right, so let's go ahead and crunch that on our calculator. Let's get him into the picture here. One moment, please. All right, so what I'd suggest is go ahead and start with the stuff in parentheses. Let's move this over so we can see a little better. Okay, so we got 600. Let's clear this out. So we got 600, and then minus, and we use the parentheses here, we've got 40, or 4 times, then 40. There we go. Not that the order really mattered. So our demand says we get 440, and then we're going to take that times, let's move them over here if I can, times the price of the jeans, which is 40 bucks, which still seems a little high to me, but what do I know? So times 40. So their profit on this particular jean is going to be 17,600. Actually, not their profit, their revenue. There is a difference, okay? Revenue is kind of like your gross earnings. So they make $17,600. Now they're not taking into account yet the price of the materials, the labor costs to make the jeans, ship the jeans, that kind of thing. They're not taking that into account yet. So this would be like our gross profits. Okay, our net profits would be after we would subtract all that stuff off. Okay, little business lesson on the side here, right? Okay, we're still good? Okay, cool. Let's pop this guy down and move on. All right, so this one says identify the rule for the domain when we have f over g. And then it says f of x equals 2x, or excuse me, x squared, my bad. X squared plus 3x minus 28, and g of x is x plus 7. Okay, so that would look like this. So they're just saying we're going to have the f function on top. So it's x squared plus 3x minus 28, right? And that's going to be over x plus 7. Okay. So it says identify the rule. So that's the rule. That's just putting one over top of the other. That's easy. And then it talks about the domain. Now, we've always said that the domain is all real numbers if you can answer these questions with the word no. So the first one is, do we have any x's underneath the square root? No. Second question is, do we have any x's at the bottom of the fraction? Uh-oh. In this case, we have to say yes. So this means that the domain will not be all real numbers. There will be some sort of restriction. There will be some possible value or values of x that will not work. Okay. So the thing we're always looking for when you have an x in the bottom of a fraction is we're looking for what number can we put in for x that will make the bottom of our fraction 0, because we know having the fraction with a 0 on the bottom is a big time no-no, right? Math guys hate that one, big time, right? So in this case, what number would I put in for x that would make x plus 7 equal 0? So what number plus 7 equals 0? Yeah. So before we go any further, all we have to note on this particular thing is that x cannot equal -7. Everybody else is good. -7, not so much. Okay. All right. So that being said, chances are pretty good, especially in a math class like this. Chances are pretty good when you have an x squared upstairs and an x downstairs that you can probably factor this guy and be able to cancel out some stuff on the top and the bottom. Well, the only thing we could possibly cancel out here is x plus 7, right? So let me show you a useful little hack for this. So the bottom is going to be x plus 7, right? Now, so we're assuming that they want to be able to cancel that guy out, right? So let's say that one of our factors up here is x plus 7. Okay. How do we figure out the other guy? Easily. Check this out. All you have to do is you say, all right, let's switch colors. I have minus 28 here. If I take minus 28 and divide it by positive 7, what do I have left? So negative 28 divided by 7 gives you what? Nope, not 3, because 7 times 3 is 21. Okay, 4. But remember, once again, we've got 4 is right, but we've got minus 28 divided by 7 equals 4, but don't forget we got to bring this negative sign along. Okay, so this one would be minus 4. Okay, and as it turns out, if you multiply those two together, you'll get this guy back. Okay, so that's a good little hack for this kind of stuff, because typically they want those guys to cancel out. So then this will cancel out, right? So the new rule of this thing is just going to be x minus 4. Okay, but this still stands. Even though now if you plug in -7, you can get -11, right? But in the original function, you couldn't do that. So that still stands up. This is just a reduced form of the original function. They love this stuff in calculus, by the way, where they have something like this, where there's a number that doesn't work, but then they do some operations to the function, and then it would work, but it won't work on the original function. They got a fancy name for this and everything. The calculus people call this a removable discontinuity. Ooh, yeah, fancy. So that just basically means in the original function, you couldn't use a -7. Okay, you have to keep that in mind. So that guy up there still stands, but we could still write our new rule as this. Okay. Well, like I said, I'm not going to bore you with all the details on that one. That's all we really need to know here. Questions? All good? All right. Let's check out a few more. All right, so this says evaluate each. What is going on here? All right, so this is what's known as a composite function. Okay. And what's really going on here is we kind of read it like a roadmap. All right. So we start with this part. G of 3. Okay. What does that mean? Well, up here is G of X, right? So G of 3 means wherever we see X, we're going to plug in a 3. Okay. So then G of 3 is the same as saying -7 times 3. So it just means plug in a 3. Okay, that's their math lingo. So -7 times 3, that's -21. Okay. So then it says f of g of 3. Well, we just figured out g of 3 is 21, so then this would become f of -21, excuse me, of -21. Okay. So how do we figure that guy out? Well, in this case, instead of being f of x, it's f of -21. That means this guy here is going to be -21, this x right there. Okay. So then we would rewrite this, and this would be 4 times -21, and then -5. So we need to do a little number crunching here. So the calculator city, right? So bring him over here, and we're going to do, clear it out. Go 4 times -21. That's -84, and then we subtract 5 more. That's -89. Okay, so that's our answer. It's a very sad 9. Even worse than normal. Not much better, but okay. So that's what they mean by a composite function. Okay. So what's really happening? Think of this like a manufacturing process. We've got some raw materials here. In this case, our raw materials are going to be 3. So we're going to feed 3 into this process here. And this process is g of x. Okay, so what comes out the other side? Well, what comes out the other side, we figured out was negative 21. Okay, so then that's the first stage of our manufacture. Then your next stage is we're going to feed the minus 21 into another machine, and this machine we're going to call f of x. And then what comes out the other side, in this case, is minus 89. Okay. So that's kind of what's happening, is whatever number they give us, in this case, we're going to feed into the g function and get an answer. So it comes out the other side. So we feed logs into one side and drumsticks comes out the other side. Okay. Then we take the drumsticks, we feed them into the next part of the process, and toothpicks come out the other side. Okay. So it's the same kind of thing. It's like a two-step process. So we feed the 3 into the g function, come up with an answer. Take that answer, feed it into the f function, come up with a final answer. Does that make sense? Cool. Okay, so let's notice that our next one, I'm going to bring up another screen for this. Our next guy here doesn't have a number. So what do we need to do with that? Well, first of all, we've got way too much writing here, so we're not going to have enough space. So we're going to go ahead and this is called duplicate the slide, which is a great thing. All right, so let's just erase the rest of this stuff. We've already done the first problem here. So give me just a second. Eraser, there we go. Get rid of all this stuff. Like I say, all this is on the previous slide, so we're good. Almost there. In case we need the extra space, we'll have it. Okay. So here's what we do. So this one doesn't give us a number. It just says g of x. Okay. So what we're going to do is we're going to take the whole function g of x, which in this case is minus 7x. And we're going to plug that in there. Okay. So this will become f of minus 7x. All right, so what does that mean? Well, that means this. Here's our f function, right? That's this guy. So you remember before when it was just a number, we'd plug the number in, right? Well, we got a little more than a number this time. We've got minus 7x, but that's okay. So what we do is the original guy is 4x minus 5. Now before we just plug in a number, this time we're going to plug in an entire function, which in this case isn't too bad. So what we would do is we say, okay, instead of calling this x, we're going to call it minus 7x. So our final answer is not going to be just a regular number. With these guys, you'll get a number. With these guys, you will not. Okay? So then to finish this up, all we have to do is we just do a little distribution here, right? So I go 4 times minus 7, that's going to be minus 28. Bring the x along for the ride. Right? And then there's no variables here, so you just bring the minus 5 down, and you're done. That's it. Now those can get a lot more complicated than that depending on what the expressions are, but not too bad, really. So all we're asking, when they give you f of g of x, you're going to get an answer that isn't just a number, which we did, and they're asking you just to take the entire g function and plug it in wherever you see x in the f function. And that's a composite function. Now, here's the thing. If we do that, then if we go back in and we plug in the 3 like we had here, let's see what happens. So if we do, let's bring the calculator up. So clear it out. So if we do 28 negative, and then times 3, and then minus 5, we get negative 89, just like we did in the last one. Okay? So the point is with this, once you get a rule of the composite, you can plug in any number and get your answer right away. Or in the last one, we kind of had to do this two-stage thing. So if we have this guy, this is like putting our two machines together, okay? And we would feed in the 3 on one side and we would get the 89 out the other side. So it's kind of like cutting out the middleman. All right? Any questions? Cool. All right. So let's try a couple more of these, and then we'll probably call it for today. All right. So I'm going to go ahead and duplicate this slide now before I write all over it, so we can do both problems here. All right. So same deal. Looks like they're using the same functions, right? This time we're plugging into f first, right? So we're going to plug 2 into f. So instead of being x, that's going to be 2. So we do 4 times 2, that's going to be 8. 8 minus 5 is 3. So f of 2 is going to equal 3. Okay, cool. Now, we take the 3, and now we want g of f of 2, but we know that we know f of 2 is 3. So this is going to be g of 3. So that means we're just going to plug a 3 in right here. Right? So negative 7 times 3, that's going to be minus 21. And that's our answer. Okay? So notice we have the exact same functions. And the last one we did f of g of x. So we plug g into the f function. This time we're going to take and plug f into the g function. Now, the question is, if you look at this, is this like multiplication? Is f of g of x going to be the same as g of f of x? Or are they going to be different? What do you think? Yeah, they are going to be different. I mean, normally you would think, you just switch the order, but the order doesn't matter. Well, the order does matter in this one. Good. So you notice that. All right, so let's go ahead and do that. So then we'll say, all right, so this time we're going to take the f function, this whole thing, plug it in every place we see x, all right? So let's go ahead and do that. So then we're going to have minus 7, and instead of calling it x, we're going to call it 4x minus 5. Okay, so then we distribute. So we do minus 7 times 4, that's going to be minus 28x. And then minus 7 times minus 5 is going to be plus. 2 minus 6 gives you a plus 35. So that's our guy. And as we notice, we pop back here for a second. When we did it the other way around, we got minus 28 minus 5. Here we got minus 28x plus 35. So they're kind of close, but they're not the same, are they? So good call on that one. They do end up being different. Okay. All right, so that went a little faster than I expected, so let's maybe do the next one, and then that'll be it. Okay, so this, what I call fog and Goff, this is just another way of writing this. Okay, I prefer this way because this way kind of tells you what to do. But this is just another way to do this. So really, this is the same as saying f of g of x. Okay, so this is telling us to take the g function and plug it in to the f function. And I better copy this one right now because I don't think we're going to have enough room for the next one. So go ahead and do that. All right, so go ahead and erase this part first. Just a second. All right, so we'll come back to this later. All right, so let's go with this one. All right, so g of x this time is this stuff right here. So we're going to plug that in wherever we see x. Look, there's x here and x here. Ooh. Now see, this one's going to take a little work. Okay. So the first one, we've got x squared and then plus x. That's our f function. So instead of calling it x, we're going to call this 9 minus 2x. And we're going to call this 9 minus 2x. All right, so we got some work to do here. So here's the thing. Remember, this is the hack for when you're squaring something. You square the first number. So 9 times 9, that's going to be 81. Right? You square the second term. Minus 2x and minus 2x. Minus 2 times minus 2 is going to be plus 4. Right? And then it's going to be x squared. The way we figure out the middle guy is you multiply 9 times negative 2. That's negative 18, right? But that's going to happen twice. When you FOIL, that happens twice. So we're going to take negative 18 and multiply that by 2. So it's going to be negative 36 and then x. Now again, if you're not comfortable with that, you could still write like 9 minus 2x and then times 9 minus 2x and FOIL that guy out. Okay. All right. So you can still do it that way, and you'll get the same answer. Okay. And then we still have to add. Oh, so what happens is let's look at it over here. If we multiplied these guys together, just do it in FOIL. All right. Color here. So if you do negative 2x times 9, you get minus 18x. All right. Then if you do 9 times negative 2x, this is supposed to be an x. Okay. You get another minus 18x. Minus 18 and minus 18 is minus 36x. Okay. So what we discovered over time is it's like if I multiply these two guys together, I get minus 18x. But I know that's going to happen twice because it happens twice when you FOIL it. So that's how we get the 36. Okay? Like I said, if you prefer this, that's fine. Because then over here, you'd multiply 9 times 9. There's your 81. You multiply minus 2x and minus 2x. There's your 4x squared. And then this gives you your middle term right there. So if you'd rather do it that way, that's fine. Okay, I like to present different things that you guys can do. But you decide which way is the best for you. Okay? Great question. All right, so then to wrap this thing up, now we have to add 9 and then minus 2x. So then we just have to put our terms together. So here we've got an x squared. We'll write him first. That's going to be 4x squared. Right? Then we go with our x's. So here's minus 36x and minus 2 more x, so that'll be minus 38 x. And then we've got our 81 plus 9, so that's going to be plus 90. And there's your final answer. So this one was quite a bit more work than the last one we did, right? And that was because we had to like plug it in and square it. We had to plug it in again. We had to add them together. There's a little more going on with this one. Okay, but that's how it is. And on that happy note, we should probably stop. But we'll do some more of this stuff again tomorrow. All right. So obviously I've got you for attendance already. So thank you for stopping by, and we'll see you next time.